Hello, thank you for watching this video. So in this video, I'm doing question 4 of May, June 2024 question paper mathematics paper 2. The topic is the analytical geometry of circles. So I'm going to read question 4 statement and then answer the questions that follow. So let's go. They are saying in the diagram, the circle centered at C is drawn. A and B are points on the circle. E is the midpoint of AB. So it's what you can see here. So we have this circle here, this right circle that you can see. This right circle have the center C, which have coordinates 2 and P, right? So you are told that B and A are points on the circumference of the circle. So your A is on the circumference here, and your B is on the circumference there. They also went on to say that this point E is the midpoint of the line AB, or maybe of this chord AB. That's what they are saying. No problem. They are saying now, 4.1, calculate the coordinates of E, the midpoint of AB. So what they want us to do, they want us to calculate the coordinates of E, and we're told that E is the midpoint of AB. So you want the midpoint of A and B, that's what we're looking for, right? How do you do this? So to do this, you know very well, that's okay. I have my A with coordinates 5 and 1, right? I have E, the midpoint, with coordinates X and Y, which you don't have. And you have B with coordinates what? -3 and -3. So what you want the coordinates of E. And you're told that E is the midpoint, which means this length BE is equal to the length EA, which is these two distances are equal, right? No problem. So you know very well, if you want the X coordinate of a midpoint, right? Yes. It's X1 plus X2 all over 2, and the Y coordinate of a midpoint is Y1 plus Y2 all over 2. In this case, your midpoint is E, right? So your X coordinate of E is equal to what? X coordinate of A plus X coordinate of B, because this one is the midpoint. So it's going to be the X coordinate of A plus X coordinate of B all over 2. Y coordinate of E, which is this one, will be equal to the Y coordinate of A plus Y coordinate of B all divided by 2. This is what you have. Once you have this, the only thing that you're left with is what? It's just to substitute. So the X coordinate of E is equal to, what is the X coordinate of A? It's 5. Plus the X coordinate of B, which is -3 all over 2. And the Y coordinate of E is equal to, what is the Y coordinate of A? It's 1 plus the Y coordinate of B, which is -3 all divided by 2. Are we here so far?
Yes.
So, which means now the X coordinate of E is equal to what?
1.
X coordinate of E is equal to 1, and the Y coordinate of E is equal to? It's equal to?
-1.
Y coordinate of E is equal to -1. So the coordinates of E is -1,
No, it's 1.
is 1, which is the X coordinate, and -1. So those are your coordinates of E. Are we happy so far?
Yes.
No problem. Move to 4.2. So what are they saying at 4.2? They are saying calculate the length of AB. Leave your answer in the set form. So they want us to find the length or the distance AB, right?
Yes.
What is A? Your A have the coordinates 5 and 1, right?
Yes.
And your B have coordinates what? -3 and -3. So they want you to find the length of AB or the distance AB. So you know very well that if you want the distance of AB, it will be equal to what? Equal to X coordinate of A minus X coordinate of B all squared plus the Y coordinate of A minus the Y coordinate of B all squared. Are we happy so far?
Yes.
Then what we're going to do is, okay, distance of AB is equal to the square root, X coordinate of A, what is it? It's 5. Minus X coordinate of B, which is what? -3 all squared, right?
Yes.
Plus, what is the Y coordinate of A? It's 1. Minus Y coordinate of B, which is minus 3, all squared. So the distance of AB is equal to the answer to this. What is it?
4 root 5.
It's 4 root 5. That's what we have as our answer. That's what we have as our answer. So what we should do, let's get all the information that we have. The coordinates of E is 1 and minus 1. So here it's 1 and minus 1. Everyone happy?
Yes.
And now we just found the distance to be 4 root 5, which means this length here, this length here is 4 root 5. From here to there is 4 root 5. Everyone happy so far?
Yes.
Okay. Then we move on to the next question, which is 4.3. They are saying, determine the equation of a perpendicular bisector of AB in the form y is equal to mx plus c. Right? Let me read it again. They are saying, determine the equation of a perpendicular bisector of AB in the form y is equal to mx plus c. So, they want us to find an equation of a perpendicular bisector of AB. Right? So, and they want it in the form y is equal to mx plus c. They want an equation of a perpendicular bisector in this form, right? So what they're looking for, or what they're asking you to find, essentially, they want to find a straight line that is a perpendicular bisector to AB. That's what they are saying. Because if they are saying what they say equation of a perpendicular bisector. They say they want an equation of a perpendicular bisector in this form, which means this straight line of yours should be perpendicular bisector to AB. Now, the question becomes, what is a perpendicular bisector? So, looking at two terms, perpendicular and bisector. What does perpendicular to AB means? It means the equation that we're looking for should be perpendicular to the line AB. Are you happy with that? So, you're saying, actually, let me write these two terms. They said perpendicular, bisector. So, these are two terms. So, you need to understand them. So, you want a straight line that is a perpendicular bisector. So, to AB. So, by perpendicular part, it means a straight line should be perpendicular to AB, which means the straight line should be at 90 degrees to AB. That's the first part, perpendicular to AB, right? And it should be a bisector of AB. What does a bisector mean? Bisect means cut through the midpoint or cuts into two equal parts, right? The straight line of yours that you want to be perpendicular to your AB. First should be perpendicular to AB. The second part should be a bisector, which means cuts through the midpoint of AB, which is what? Which is E. So you want an equation of a straight line that is perpendicular to AB, right? And passes through E, because E, that's a midpoint, and saying you want a perpendicular bisector, you want a straight line that will pass through the midpoint of AB, or will cut AB into two equal parts. Because if a straight line passes here, this part is equal to that part. We've indicated that already. So what we need to find a gradient that will be perpendicular to AB. Are you with me? Once we find that equation that is perpendicular to AB, we want a straight line with that perpendicular gradient that passes through the point E. Are we happy?
Yes.
So let's go and find the gradient of AB. So, we have A, which is 5 and 1, right? We have B, which is minus 3 and minus 3. So the gradient of AB is equal to y of A minus y of B over x of A minus x of B. Y of A, what is y of A? The y of A is 1 minus y of B, which is minus 3 over x of A, which is 5 minus x of B, which is minus 3. So what is your answer to this?
1 over 2.
Your gradient for AB, therefore, your gradient for AB is equal to 1 over 2. Are we happy?
Yes.
That's the gradient for AB. So that gradient for AB is 1 over 2. But now, what we want the equation of a line that is a perpendicular bisector to AB. We want that equation to have a gradient that is perpendicular to that of AB, which is perpendicular to this one, and must pass bisector through the midpoint or cut your line segment into two equal parts or two equal sections. So it should pass through E. So what we need to find now, we need to find that gradient that is perpendicular to this one. Right? Yes. Once we find it, then we can find a line that passes through E, because we're told that your line is a bisector of AB. This is a perpendicular bisector of AB. So what do we do? It's okay. If we want a perpendicular gradient, we know that, okay, it's okay, the gradient of AB, right? Yes. Times the gradient of that is perpendicular to AB. Yes. It should give us what? Minus 1. Minus 1. Right? Yes. No problem. Because you know that if two gradients are perpendicular, or two lines are perpendicular, the product of their gradients is minus 1, provided that they are not vertical and horizontal. Right? Yes. No problem. Then we have the gradient of AB to be what? 1 over 2 times what? Times M perpendicular is equal to minus 1. So this times this is 1 over 2. M perpendicular is equal to minus 1. Right? Yes. Then divide by half. Divide by half. Therefore, your gradient, your perpendicular gradient is equal to minus 2. This is your gradient. Are we happy so far? Yes. Fine. So which means now, we know that a line that will pass through E have a gradient of what? Of minus 2. So we know that our line is not passing here, it passes through E. Our line passes through E. Are we happy with that? Yes. So, and the gradient of this line is equal to what? It's equal to minus 2. Let me emphasize something. Are you guys happy with the perpendicular part? Because we're told that the line passing through the midpoint of this line should be perpendicular to the gradient of AB, right? Yes. The bisector part means passes through the center or cuts your line segment into two identical parts or two equal parts. Are you happy? Yes. That's why we know that it passes through E. Because if you have AB and E is your midpoint, a perpendicular bisector to this line will pass through E at the midpoint. So now what we need to find is a line that have this gradient and passes through E. Are you guys happy? Yes. No problem. So what do we do? It's okay. Y will bring the form Y is equal to mx plus c, like we're told there. We know m is what? Is minus 2. So your y is equal to minus 2x plus c. So what you need to find now is the value of c. But you know the coordinates. You know at least one coordinate that lies on that line. Well, that coordinate that you know is the coordinates of E. Because you know that E is a midpoint of AB, and that's why your line is passing. If you have a bisector to that line segment AB. Then what do you do? It's okay. I have the coordinates for E to be what? To be 1 and minus 1. Then now I can substitute my x and my y on this equation. I will be left with c as an unknown. So what do you do? It's okay. Minus 1, which is equal to minus 2 times 1 plus c. So minus 1 is equal to minus 2 plus c. So c is equal to 1. Are you happy? So now the equation that is a perpendicular bisector to the line segment AB is y is equal to minus 2x plus 1. So this is the equation that we are interested in. So it's this equation here of a perpendicular bisector. So y is equal to minus 2x, right, plus 1. The equation of this line. Is everyone happy with this? Yes. Are you happy? Yes. No problem. So I'm going to clean the board and then continue to the next questions. Happy? Yes. Baby? Okay, so now we're doing 4.4. 4.4 read as follow. They are saying show that P is equal to minus 3. What are they saying? They are saying show that P is equal to minus 3. What is P to begin with? Look at this diagram. It won't be difficult to find that P is the y-coordinate of C. And C is the center of this circle. Are you guys happy? Yes. So, it's not difficult to see that you C have the coordinates 2 and P. And P is the y-coordinate of C, and C is the midpoint of this circle. That's what we have. That's what we're told, because C is the center of the circle. That's what we're told. So, what do we do? In this case, maybe we don't have a lot of options. But what we can say is, you might remember this from our Euclidean geometry classes, right? Yes. That if you join a line from center, right, to midpoint of a chord, because this is a chord, because a chord is a line segment that joins 2 points on the circumference of a circle, right? Mm-hmm. So if you draw a line from this side, this circumference, and joining the other side, it's a chord, a straight line segment. Even the diameter, if you think about it, it's from the diameter is from the circumference, passes through the center to the other side of the circumference. A diameter is also a chord by definition. Are you guys happy? Yes. No problem. So if you might remember, I think maybe it's the second theorem of our Euclidean geometry classes. We said that a line from midpoint, from center of a circle, to the midpoint of a chord, which means if you draw a line from the center, which is C, to a midpoint E of a chord, it is perpendicular to the chord. Are you guys happy? What I'm saying is, if you draw a line from the midpoint from the center of the circle to a midpoint of a chord, that line will be perpendicular to the chord. Are you guys with me? Yes. Fine. Then, what you see yourself having, you're having this line segment, CE. Do you see CE? CE, you know that C is from the center to a midpoint of a chord, right? And also perpendicular to the chord. So what you have there, by definition, is a perpendicular bisector of a chord, right? Which you have to be that. You have the equation of a perpendicular bisector to be that. Let me repeat this thing again. If you join C to E by a line segment, you will be joining a line from center to a midpoint of a chord, because this is B is a chord. So E is the midpoint of that chord. So if you join a line from center to midpoint of a chord, it is perpendicular to the chord by those theorems, by the second theorem, right? So now what you're having now is CE perpendicular to AB and also bisecting AB. So what you have by definition is a perpendicular bisector, which is the line that describes CE, also lie on this equation. CE is also defined by this equation. So which means the equation of CE is y is equal to minus 2x plus 1. Because CE is the perpendicular bisector of your line AB. Are you with me? I can go further and say, remember, from the third theorem, when we're doing the third theorem of Euclidean geometry, I said that it states that a perpendicular bisector of a chord passes through the center. If you have a chord AB and you are asked to find a perpendicular bisector of that chord AB, it is given that you should know that it passed through the center. So which means your center, which is your C, also lies on that perpendicular bisector of a chord, on that line that was a perpendicular bisector of a chord. So which is the same thing as what we just said here. Are you guys happy? So in that case, we have coordinates of C to be incomplete, to be 2 and P. So we're asked to find the value of P, which means we have half the coordinates of C, and you have the equation in which C is lying on. C lies on this line. You can see here is C. C lies on the perpendicular bisector of AB. So in that case, what you do, okay, I'll say, okay, this is my x value, this is my y value. So substitute these things on this line. That defines C as well. So what you have P is equal to minus 2 times 2 plus 1. What is the answer to this?
Minus 3.
Minus 3. We've done what they want us to show. Your P is equal to? Minus 3. So I'll put minus 3 here. We're done here. So we move to 4.5. What are they saying at 4.5? At 4.5, they are saying, show by calculation that the equation of a circle is defined by x squared plus y squared minus 4x plus 6y minus 12 is equal to 0. They are saying, show the equation of a circle, right, is x squared plus y squared minus 4x plus 6y minus 12 is equal to 0. They want us to show that the equation of this circle is this one here. Are you guys with me? No problem. So you might remember when we started doing the equation of circles, I said that the equation of a circle is the standard form, or the very popular of common form, is x squared, x minus a all squared plus y minus b all squared is equal to r squared. Are you guys with me? And I said that a and b are what? Are the coordinates. Are the coordinates of the center of your circle. A and b are the coordinates of the center of your circle. So this is the skeleton that you use to find the equation of a circle. So what you see here is an expanded version of this circle. Are you guys with me? So you know that A and B are the coordinates of the center. What are the coordinates of the center there?
It's 2 and minus 3.
So the coordinates of the center is 2 and minus 3. So what do? You substitute these things there. So what you have is, you have x minus 2 all squared plus y minus -3 all squared is equal to r squared. So you have x minus 2 all squared plus y plus 3 all squared is equal to r squared. Is this equation complete?
No.
Are you happy having x on the equation?
No.
Yes. X is a variable. So like this one that you found, you see, here there was x there. So x is a variable. So it's fine. So are you happy having x as x on this equation?
Yes.
Are you happy with y?
No.
Are you happy with r? No, r is a problem because r is a real number. It's not our variable, at least to grade 12 maths. So you must go and find the numerical value of r. Are you happy? How do you find the numerical value of r? I said that if you, in any equation, if you have mostly variables and one unknown, you just need 1 point. Right? You need 1 point that will have x and y value. Then you'll be left with the square of r that we're looking for. Are you guys happy with me?
Yes.
So is there any point that we have on the circumference of the circle?
Yes.
Because the point that you should use, it should lie on the circle. It should not be inside the circle. It should lie exactly on the circumference of the circle. Like when you're finding the equations for a parabola, you would need 1 point that lies on the parabola itself. Are you guys happy? So in that case, we do have a point, 1 point, what is it? Maybe let's say it's -3 and -3, which is what? Which is B. Are you guys happy? So substitute the x value and the y value here and there. Then you'll be able to find the square of r. So what do? Say, okay, -3 minus 2 all squared plus -3 plus 3 all squared is equal to the square of r. What is the answer to this?
25.
25 is equal to the square of r. Are you guys happy?
Yes.
So now you have found the value of this thing to be
25.
25. So your equation is complete now. So what do you say? So your x minus 2 all squared plus your y plus 3 all squared is equal to 25. Now, my question is, have you shown that this is equal to that? No. What you need to do is to expand this now. Are you happy? You must expand this, which means we have x minus 2 all squared, or x minus 2 times x minus 2 plus y plus 3. Y plus 3 is equal to 25. So what you need to do now is to multiply these brackets out. If you multiply correctly, you'll find that we have x squared minus 4x plus 4, right?
Yes.
Plus y squared plus 6x plus 9 is equal to 25. Are you guys happy?
Yes.
I'm going to, if you look there, we had 0 on the side, so let's transpose this to the other side. So x squared minus 4x plus y squared plus, I think this should be 6y here, plus 6y. Then you have this 4 and this 4
It's 13.
plus 13 minus 25 is equal to 0. So you group these two together, so it's x squared plus y squared, but I don't think you have to. Plus y squared
Minus 4x
minus 4x
plus 6x
plus 6y. What is the answer to this? Minus 12 equal to 0. This is exactly that. And we're done. Any questions? I think it's straightforward. Then we'll move to question 4.6. Question 4.6 is 6 marks, and I think I might need more space. So what I'll do, I'll clean all of this, question 4.4 and 4.5. Hopefully all the information is there. Then we'll do, actually let me just write the equation of this circle here. Maybe just write it here. X squared plus y squared minus 4x plus 6y minus 12, right?
Yes.
Equal to 0. So this is the equation of our circle, this. Are you guys happy?
Yes.
I'm going to clean 4.4 and 4.5, then we'll do 4.6. Let's go. Okay, so now we're doing 4.6. 4.6 reads as follows. Calculate the values of t for which the straight line y is equal to tx plus 8 will not intersect the circle, right? They want the values of t. What is t? What is t?
Gradient.
T is the gradient because this is a straight line, right?
Yes.
The coefficient of x is always the gradient. So t is a what? Is your gradient. So they want the possible values of your gradient, right?
Yes.
For which a straight line that have a y-intercept like that will not intersect the straight line, will not intersect the circle. So, unfortunately, I can't even draw. Let me try to draw something similar that would explain this, right? Let's say, so let's say you have a circle here. Here is it. I'm trying to draw the circle, but it's not accurate. You have a straight line that have a y-intercept like that. So that straight line, this y-intercept maybe 8 is here, right? So if you draw a line like this, you can see that this line is touching here, right?
Yes.
If you draw another line here, it's touching there as well, right? So I don't know the gradient of this line, right? I'll just make an example. This gradient is positive, more or less, right? So let's say maybe it's 2. Do you agree?
Yes.
And this gradient here, let's say maybe it's minus 2 because it's negative. I'm not saying it's 2 and minus 2. I'm just making an example. So the line that we have here is something like y is equal to 2x plus 8. Are you happy?
Yes.
And this side is something like y is equal to minus 2x plus 8. Are you guys with me?
Yes.
Okay. If you move this line anywhere in between these two lines, it will intersect the circle. Do you understand? But if you move this line away, if you move this line away from this line, which you move it to the side, will it intersect the circle?
No.
If this one moved to the side, will it intersect the circle? No, it will not. So there are specific values of a gradient, right? Which maybe should be between these two, I think, at which t must be in order to intersect the circle. Do you understand? So if your line is in between these two lines, then if your line moves anywhere between these two lines, it will intersect your circle. But if maybe it's on the other side or this other side, it will not intersect the circle. Are you guys with me? So what you want to find now, you want to find the possible values of the gradient for which your line similar to this will not touch the circle. Are you guys with me? Is it clear? Okay, no problem. So I'm done explaining this now because I'm just trying to give you the visual representation of it. Because all the lines that will be between here, all the lines from this point that are in between these two tangents will intersect the circle. But others that are outside this tangent, like on the other side, which is, I would say, less steeper and more steeper one, those two will not intersect the circle, or those ones will not intersect the circle. So in this case, in order to find this T so that the line does not intersect the circle, we say now, we know that we have this equation, right? This straight line, y is equal to tx plus 8. And the equation of the circle, which is x squared plus y squared minus 4x plus 6y minus 12 equal to 0. So you want this line not to intersect this. Are you guys with me? You want this straight line not to intersect this circle. So if you want this straight line not to intersect the circle, you know that if you try to solve these two, there will be no solutions for it. Because they do not intersect. So there are no real values of x and y where these two things intersect. Are you guys with me?
Yes.
So which is we have non-real solutions if we try to solve that equation over there. Are you guys with me?
Yes.
So what will I do? So now I know that these two things will not intersect and they will yield or they will give me non-real roots at the end. So let's try and solve as if we think there will be a solution, knowing that there won't be any solution. Are you with me? So you know how to solve these two equations. This is simultaneous. This is 1.2. Solving simultaneous equations. So what do? We have y to be this. We substitute it there and there. Are you with me? So what do we have? We have your x squared plus your y squared. What is your y? Your y is tx plus 8. So you have tx plus 8 all squared plus 4x. Are you with me?
Yes.
Plus 6y.
No, it's minus 4x.
Or it's minus?
Yes.
Okay, good. Plus 6y. What is your y? Is tx plus 8, right? Are you with me? We're here, right?
Yes.
Minus 12 is equal to 0. Yeah. Then we're trying to solve this equation. But we know that this equation will not have real solutions because these two things do not intersect. So if two functions or maybe two graphs do not, or two curves do not intersect, you know that the solutions will be non-real. Right? Yes. Fine. What do? So okay, x squared plus, what is this? You expand these two brackets. If you do, you'll find that you have t x all squared, right? Plus this times 2 is 16 tx. Are you with me? 8 times 8, what is it? Something like 64. Are you guys still following?
Yes.
So, fine. So what do we have? Or maybe, if you want, if it's very difficult, you can just say here, t squared, x squared. The same thing. Because say, this times this, when you have those two brackets out. Open these two brackets, and it's tx plus 8 and tx plus 8. So this part is this. Multiply this bracket out, we'll get this at the end. So that case is minus 4x. Are you with me?
Yes.
Plus 6 times tx, that's 6tx. Right?
Yes.
This is 6 times 8. That's like 48. Right?
Yes.
Minus 12 is equal to 0. Are you guys with me?
Yes.
No problem. So what do? We collect the like terms. So this and this, these are like terms. Do you see them?
Yes.
These and these are like terms.
Which one's?
This one and this one.
X squared.
So the coefficient of this one of x is what? Is 1, right?
Yes.
You are adding it. The coefficient of x here is what? Is of x squared is 1. We're adding with what? With t squared. X squared. Are you following?
No.
It's x squared plus t x squared. If this was 2, you're going to say 1 plus 2, and it will be 3x squared.
Yes.
Are you guys with me?
Yes.
If you have 1 here, if this t squared was 2, you're going to say 1 plus 2, we'll say 1x squared plus 2x squared, and the answer is going to be 3x squared. But you don't have 2, then you have what? You have t, here is it? It's the same thing.
Oh, okay, I see.
Are you following?
Yes,
Okay. Then, so we're done with these 2 plus. Let's go to those that contain x. This is 16,
that's 6.
16tx, right?
Yes.
And there is one with x. So here is one with x here. There is one with x there. There is one with x there. Are you with me?
Yes.
So you have 16tx plus 6tx. What is that? Sound like it's 22. 22tx. Are you with me? Because you go 16tx plus 6tx. So you add the coefficient, the numbers. So it's going to be 22tx. Yes. Then there's that minus 4x over there. We'll deal with it later. Are you happy?
Yes.
No problem. Then let's go to the numbers. So we have this number here. We have this number over there. We have this number over here. So you have 64 plus 48 minus 12. Sorry?
100.
It's 100 plus 100 is equal to 0. Are you guys with me?
Yes.
We're not done with the common factors because there's this situation here. So what do we do? It's okay. 1 plus t squared x squared plus these 2. These are like terms because they both contain x. Right?
Yes.
So pretend that this t was not there. You are going to say 22 minus 4. Right?
Yes.
And your answer will be something like 18.
Yes.
18x. Are you with me?
Yes.
But now this 22 is there. So what you do, you're going to treat it the same way you did there. You're going to add 22t and the 4. What are you going to get? You'll get 22t minus 4. All of these are grouped as x. Are you following, Z?
Yes, I am.
Okay. Plus 100 is equal to 0. If you look at this, you will see that you are looking at a quadratic equation in the form ax squared plus bx plus c is equal to 0. This is your a, this is your b, and this is your c. But this quadratic equation of yours, this one that you're looking at, does it have solutions?
It doesn't.
No, it doesn't have solutions because these things do not intersect. So the roots are non-real. If the roots are non-real if the roots of a quadratic equation are non-real, what does it tell you about the discriminant?
It's less than 0.
The discriminant of this thing is what? Is less than 0. The discriminant is less than 0. And the discriminant is b squared minus 4ac. This is less than 0. Are you guys following?
Yes.
No problem. So what do we do? What is your b? Your b is this.
It's
22t
minus 4.
all squared. Minus 4a. What is your a?
It's
1 plus t squared. What is your c?
It's 100.
It's 100. Are you guys following?
Yes.
And this is less than 0 still. So what do we do from here? Just solve for t then. The values of t that will satisfy this condition. So what is 22 times 22?
It's 484.
484 t squared, right?
Yes.
22 times 4 times 2
It's minus 176.
minus 176 t. What is 4 times 4?
16.
16, right? So we're done with this part. It's what we have here. So in this case, so you can say 4 times this, 4 times that, and then whatever the answer is for here, you multiply it by 100,
Yes.
right?
Yes.
But what you do, let's just first multiply the numbers first.
Okay.
What is 4 times 100?
Minus 100.
So you have minus 400, right? times what? Times whatever that is there. 1 plus t squared. Everyone happy so far? Okay. Then, so want this to be less than 0, of course. Right? Because it should be less than 0 at the end. Let's go and deal with that part. So we have 484 t squared minus 176 t plus 16. Negative 400 times 1, that's minus 400. Negative 400 times t minus 400
T squared.
t squared is less than 0, of course. Then let's group the like terms. What is 484 minus 400?
It's
So
84.
it's 84 t squared. This one is on its own here, minus 176 t. What is this?
It's 16 minus 400, right?
16 minus 400.
It's minus 184.
Minus 3?
84.
84. This should be less than 0. You've seen this. This is question 1. But the difference is that instead of having x and x, you have t's. So you do the exact same thing. When you're here at question 4, you find the critical values.
Yes.
Question 1, critical values. Say your t is equal to, then you say 84 t squared minus 176 t minus 384 is equal to 0. Then you find the critical values of yours. So your critical values, then you say your t is equal to negative b, which is what? Minus 176, right? Plus or minus the square root of minus 176 all squared. Minus 4 into a. What is your a? It's 84 times c minus 384. All divided by 2 times 84. So this should be 4 here. So your t is equal to, or your t is equal to. Is everything clear so far? Any questions?
No.
Okay. What is t?
24 over 7.
24 over 7. And the other?
It's minus 4 over 3.
Minus?
4 over 3.
Minus 4 over 3. So you have the critical values of this. So you plot this as you normally would. But instead of having x, you have what there?
T.
T. So minus 4 over 3 should be somewhere this side. And 24 over 7 should be somewhere this side. So here is it. Is it smiling or sad?
It's minus.
It's positive. So you want it where it is less than 0. It's less than 0 here. Where the x values? These x values here. So it's all these x values here. The ones that are between
Minus 4 over 3.
and 27 or 24 over 7. So your t is an element of minus 4 over 3 to 24 over 7. Or maybe you can just say your t is less than 24 over 7 but greater than minus 4 over 3. So this is how you do this one. You just have to be careful around here. It's very easy to make mistakes there because it doesn't look very beautiful there. So
Okay. Can I ask?
Yeah.
So, was it gonna be wrong if you equated the two equations that you have the way we do on functions?
which equations?
The two equations.
This one, and this one.
Yeah.
How would you equate them? They equal to what if you equate them?
You're gonna say the one of the circle equals to this one.
But the thing is,
Then
what is one of the side? Because you don't have the reason you equate when you're doing functions. You have f of x equal to 2x minus 6 and g of x equal to negative 3x squared plus 2x plus 1. What is f? What is this?
it's all right.
What is this? So you're equating the y values. That's why you equate them in the first place.
Okay.
But what are you going to be equating? What is the y value of this one? You can't equate, compare apples and oranges. You can't equate apples to oranges. So the reason we're equating these two, because we have, this is the y value of f, and this is the x value of, this is the y value of g. And you know that they do intersect. Maybe they do not. So you know that they will be equal at that point. But in this case, you don't have anything comparable to those. You know how to solve this, because if I gave you two equations that didn't say solve for x and y, you know you use that substitution kind of solution. So Yeah, this is this one. Any more question? Okay, then I'm done here. And I hope it does make sense to you as it does to all of us here. Thank you for watching.